Heavy. Thank you. So heavy is the right answer. Other one, please. Other also response. So you can see in screenshot. Screenshots are taken from the lectures. Metals, high toughness, high stiffness, ductile, wide range of strengths depending on the composition and processing. Thermal and electric conductive. So thermal and electric conductivity is high also for metal, and reactive, low corrosion resistance. Hybrid, also we can see for go for hybrid, expensive and ductile to safe and join, and property depend on the combination of the materials. Okay, so please remember these properties also for metal and ceramics, polymers. So next question is this. Figure out the incorrect statements about the ceramic in the following. Option A, good insulator of heat and electricity. Incorrect. We have to find incorrect. Usually harder than the metal, and ductile in nature, contain both metallic and non-metallic elements. Please answer.
Metal in nature.
Okay. So C is the right answer. Please also look the properties. Stiffness high, hard, and good high temperature resistance, brittle, good corrosion resistance. These are the ceramics. These are the but we have to find incorrect statement. So metal are ductiles. We have already seen in previous slides. So C is the right answer. Glass or ceramics, you can see these are property. If you want to know, right, you can write. Okay. Next question is which of the one of the characteristic property of polymer material as compared to metal. So we have compare here polymer and metals. What is the difference between metal and polymer? Which property is superior?
Here elongation.
Okay. Other also please respond. If you have doubt, please ask. So C is the right answer. We can see properties also not please. These are the properties also. Next question. Yes. Which of the following unit cell has highest symmetry? Cubic, hexagonal, triclinic, tetragonal.
Hexagonal.
Other, please. So first we have to look what is cubic system, ABC, what is the angle, okay, for hexagonal, trigonal, tetragonal. So we have to learn about the crystal system, seven crystal system, and then we can go for symmetry. I think cubic is, we know that for cubic ABC are equal, angle are also. So option A is correct. You can see these are the seven primitive crystal systems. If we check for the cubic, we can find highest symmetry. Other system as compared to cubic doesn't. Cubic has highest because all angles, all length, so system can be folded by axis, by angle, by along the length. Okay, so cubic has highest. Which of the following is said for lowest? Next question is, you can see in this slides. Please read these systems and answer the question. You have 5 minutes.
Air cleaning,
What? You can write in chat box also. Okay. Others. So we can see in triclinic, please see all three axes are unequal. Axes are unequal, and also length and none of perpendicular, and angle also are not perpendicular to, none of is perpendicular to another. Also we can go for that. So you are you able to see systems? Diagram of triclinic, monoclinic, orthorhombic, rhomboidal, tetragonal, hexagonal, cubic. Relation between angle and ABC. Here, length, width, and height are same in cubic. ABC. A, ABC equal. Here, A is not equal to C. And there are same hexagonal, tetragonal, also not same. A not equal to C, but A and B are equal. For rhombohedral, we can see A are equal, but ABC are not equal to 90. So please learn or remember these relations. Okay. So let's come back to your question. So answer is triclinic. Okay. Next question. Higher coefficient of thermal expansion of a material is generally manifest of strong bond, thermal vibration, weak bonds, lower bond energy, thermal coefficient. So do you know about the idea of thermal coefficient? What is the formula? How we can relate? Anyone? What is the answer?
lower bond energy.
Okay. Multiple option also correct.
Bonds.
So C and D is answer. Let's see what is the how we can relate. So we can see most solid material expand upon heating and contract when cooled. The change in length with the temperature for a solid material can be expressed as alpha air is the thermal coefficient of thermal expansion. Okay, where L naught is and F is the represent respect to the origin and final length of the temperature changing from T to T final. The parameter A1 is this is coefficient of thermal expansion and has unit decimal of K inverse, temperature inverse. This is about 10 to the power minus 6 volt by Kelvin, degree Celsius also. So how to we can relate weak bond and lower bond energy? There is a relation between bond and bond length. Let's say this type L1 L2. Which length is higher, L1 or L2? Do you have idea about the bond length? Single bond, double bond, triple bond? And this is higher coefficient thermal expansion. So please relate this formula. Let first length is, let's say bond length is L1 is higher than L2. Single bond is longer than double bond in length. So here is most solid you can see on heating and contract when cool, the change in length. If alpha is high, then comment about the length, bond length or material ABC length. Please, what happened here? The length, if alpha is high, or you can relate by first above expression. Please relate. If alpha is high, when alpha is high, when change in length divided by original length upon delta T. You can also relate by that. Forget about this. Let's say del L by L naught. Now, if alpha is high, then this is also constant. What about this? Change in length also high? Yes or no? Please, if alpha is high, when difference original length and final length is should be high. Please. So change in length is high when bond if the bond is weak, then only this can be happen. Yes or no? If bond is tightly two atoms are tightly bound, if we increase the temperature, so energy should be required more. But if bond is weakly bound, then easily expand or cool, then changes more happen. Yes or no? So
Yes.
if the bond is weak, then length changing length is can be more and alpha is more. So these option is related to the higher coefficient. If the alpha is high, then weak the bond and lower the bond energy also. Okay, next question. If there are 6 electrons in the d orbital of a transition metal, the number of unpaired electrons are 6 electrons and equal to 6 and d is the orbital. Please find out the unpaired electron. I think this is the 12th level question. Please find. You have 5 minutes. Ola, please respond for this question. This is simple question. Others, please answer. I want to everyone. Please respond. You have to fill 6 electron. How? 1, 2, 3, 4, 5, 6. Like that. And now you can calculate easily unpaired electron. Do you know S, P, D, F subsets? Here is the 5, 5. 1, 3, 5, 7 are the subsets here, and each subcell can be contained to electron. First, we have to fill up one, then can be pair. Yes. So this is right answer. Let me show you. C is the correct answer. Are you clear? If somebody has doubt, please ask. Let's go for next question. Which of which among the following bond is strongly directional in nature? Which among the following bond is strongly directional in nature? Metallic, covalent, ionic, van der Waals. Please, please answer. So let me discuss. B is the answer. Covalent. In covalent bond, you can see the covalent bond are directional bond because atoms are bounded covalently and reflect specific orientation in the space relative to the one another. That's why solids have covalent bond have defined shape. So please read about also the covalent, metallic, ionic, and van der Waals, van der Waals bonds, and hydrogen bonds also. Next question. A primitive lattice unit cell necessarily has following attributes. This is question about the unit cell and also primitive lattice. So do you know the definition? What is the primitive? What is the unit cell? Option first. It contains one lattice point and not the smallest repeatable unit. Second, it is the smallest repeatable unit and contain more than one lattice points. C option, primitive unit cell has larger volume than the non-primitive unit cells. D, primitive unit cell could be any shape. So let me tell you the answer. A and D, and let's see. Primitive unit cell in a space only contain one atom. Contribution of lattice in primitive unit cell should be one, must be one. Then only unit cell called primitive. Non-primitive can be contained more than one. Okay, so this is the difference between primitive and non-primitive unit cell. So option one, it contains one lattice point and not the smallest repeatable unit. And the primitive unit cell could be any cell. If you want to read more about, you can visit this site. Okay. Let me check. 1 minute. Let me show you. 1 minute. Give me one option. That is on screen. Are you able to see my window? It is the definition about the lattice, and this is for 1D, 1D, 2D, and 3D. In 2D lattice below, you can see possible. Let's click. These are all the parallelogram repeat unit cell. These are the unit cells. The square chosen in a unit cell because it is the smallest and provide the most symmetry. Next, the smallest unit cell doesn't reflect the symmetry within the structure. And also you can read for the some lattice pattern, the smallest unit cell doesn't describe the present symmetry. It is then desirable to pick a large unit cell which does describe the symmetry. If the unit cell contain another lattice points is called non-primitive, otherwise is primitive. We have already seen primitive non sorry primitive and non-primitive clear, and these are the possible structures you can see. Are you seeing my window? Yes or no? This is in 3D. Please visit this site. Okay. So let's go for next question. The most electronegative element in the periodic table. Please answer. This is simple question, I think. Lithium, chlorine, fluorine, oxygen. Highest electronegative element. Answer is fluorine. Electronegativity here is a chi for strong electron positive. You can see 0.0 minus 0.7 to 0.4 strong electronegativity. These are the reference line, and in periodic table electronegativity higher like that, and above also is higher. So fluorine, but fluorine is highest electronegative. We have already, I think, read and learn about this thing in 12th class in periodic table. Okay. Next question: the energy of the primary bond in kilojoule per mole is the range of ABC. There are the option, and this is kilojoule per mole in unit. What will be the answer? Answer C. You can see the ionic has a greater than 100 and covalent 50 to 350, metallic 20 to 350, and secondary less than 10 kilojoule per mole. So primary should be greater than. Okay. So please remember these things also. Next, which of the following is are belong the secondary bonding type? Which type bond is secondary? Covalent, hydrogen, van der Waals or ionic? Weak bonds. Which one? Okay. So van der Waals and also the hydrogen bond. These are the second type, secondary bonds and weak bonds. Okay, please learn, remember also. The secondary bonding we already discussed arise between the charge dipole and H2. You can see van der Waals also. Next question: the bonding type dominant in the polymer material is R. This type of bonding has or have polymer? Polymer. So covalent and van der Waals. So, sir, I think already discussed covalent bond in polyethylene chain and van der Waals. So layer by layer has the van der Waals bonding. Okay, next question. Which of the following is are true about polymer materials? They have a linear stress strain curve. They have very high molecular mass. They have strength to weight ratio. They have low corrosion resistance. Polymer. Please comment about this question. So B and C, they have very high molecular mass. We can see chain. So obviously molecular mass will be high, and they have high strength to weight ratio. Okay. Next, which of the following can contribute to increase the bond energy of an ionic bond? Ionic bond. In ionic bond, how we can increase the bond energy? Last separation between the ion and the equilibrium separation. Last difference in the electronegativity and cation and anion. Increase the size of the ions, increase the charge on the ions. How we can increase the bond energy in ionic bond? Bonds are formed by ions. How we can increase energy? If the atom are bound tightly, then energy should be high. So which one option is correct? Is option B. Let's see. Last difference in the electronegativity negativity of cation and anion. If the let's say A B last difference in electronegativity. If A and B has higher, this is higher positive, this is higher negative, then force between these should be higher, then energy. These bond are tight, these atoms are tightly bound, so energy should be high. Yes, charges or electronegativity negativity difference in electronegativity and electropositivity if higher, then we know the force should be high. Other the option one increase in the charge on the ions. If the charge on the ions is high, also the bond energy is high. This is simple question I think. In the periodic table, we choose A and B. This is highly electropositive. This is highly electronegative. Negativity element. Then force between these atoms or bond between these atoms. These atoms will be tightly bound. Yes. So bond are tightly bound, then bond energy will be high. And if charge is high, also we know that's a positive, 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 negative, negative, negative. Then also the force between these two atoms will be high, or ionic bond will be strong. So clear? Let's go. Sorry, let me show you. Also here by lecture screenshot. Ionic bond. If the two atom elements has large difference in electronegativity, this is the ionic bond, and also the increase in the charge on the ions. Let's go for the next question. Which of the following is correct in the increasing the bond density order? So now we can choose the right option. We have discussed ionic bond. Take 5 to 2 minutes, 2 to 5 minutes, and response please. Think about this. That please answer. B is the correct answer. But why? We have to look for silicon, carbon, oxygen, O, LiCl, LiL. Yes. So this is highly electronegative and this is highly positive. So ion bond between these will be stronger. Yes. So I this is these are two options. This is cancelled and others. We can then this one. This is highest, then this is much as compared to this is less, then xenon, then silicon, carbon. Okay, so we have I think already discussed in previous slides how ionic bond is formed and bond energy relation, electronegativity. So please look the periodic table and electronegativity and atomic positions in the periodic table. Okay, you can easily choose the right answer. And also you can visit this site if you want to learn more about. Okay. Next question. Following attributes are necessary for a unit cell of a primitive lattice. We have already discussed primitive lattice. So please choose now right answer. Take 2 to 5 minutes. Please think and response. Find the effective number of atoms. Please 9 minutes. So option A and C is correct here. Set of the primitive unit cell is not fixed. Step can any type. Air is not fixed. And this is the smallest repeatable unit. We know the primitive unit cell has effective number of atoms should be 1. Yes. So there is a Q. Please find the number of atoms. Effective number of atoms. One can find the effective number of atoms. What is the sharing of this atom inside this Q? And other is, let's say, one is inside totally. Okay, 1 by 8 is answer is 1. Okay. So sharing of this in the cube 1 by 8 into 1, 2, 3, 4, 5, 6, 7, 8. 8 atoms should be. This is the number of effective atoms. In this, and 4 phase center, this is body center. This is simple cubic. Let's say this is phase center. Six phases and then six, like 6 atoms, and also now calculate effective atoms A, B, C. And which one is primitive, which one is non-primitive? Also comment about the ABC, primitive and non-primitive. D2 and D2 and C should be 2 and C 3. So which one is primitive and which one is non-primitive? This type calculation I think you have done in BSc or 12th. Okay, so here is also simple. One is inside and corner setting contribution is one. So total is two. So this is not non-primitive, but this is primitive. P. This is non-primitive, and this is also non-primitive because while this is non-primitive, number of atoms more than one. Okay, so prepare this type question also. So this is the smallest repeatable unit and can be any no fixed size itself is not fixed for primitive. Okay, next question is with the increasing the bond length, bond energy of the material increase, decrease, doesn't change, may either increase or decrease. Now we can define the bond energy. Please answer. We have already discussed about the bond length energy. This is simple question. You can easily answer. Think about this. Okay, others, please. Let's see if the atom A and B are separated by this much length A and B. Increase in the bond length. Let's say before AB is here, before after bond length is increased L1 L2. If L1 is less than L2, bond energy. Let's say E1 E2. What happened between E1 and E2? Bond energy can be defined as if the we have to break this bond, need that much energy, which is called bond energy. So force between these two atoms will be higher if we break the bond, and here is atoms are separated much more far. So force between two atoms is V. So energy required energy will be V. Then so E2 is less, E1 is greater. Okay. So answer is decrease. The bond length is increased, then bond energy is decreased. Yes, am I right? Clear to you? Let's go for next question. You can also read this by this side also. Next question. At the equilibrium separation between atoms, the condition satisfies are. Please answer. At the equilibrium separation between the atom, condition satisfies. Bond energy is minimum, potential energy is minimum, force is attractive, net force is zero. So net force should be zero and potential energy also is minimum. Then equilibrium can be happen. And you can see the equilibrium. This is potential curve, force here. Here is the equilibrium. Potential energy is minimized here. And net force should also be, there is a that force between atom attraction and repulsion. So attraction and repulsion force will be cancelled out and will be equal, should be equal. Then equilibrium can be happen for these atoms and potential energies there is minimum. Okay. Can you find the equilibrium? Let's say ax square, ax cube, and bx function. If you have, please find there is a, let's say, energy, potential energy. Please find the force. Do you have idea? Do you know the formula? How you can find the force, potential energy, if you know the function? Due by the x equal to 0 for what? Okay. And net force also 0. So such type question may be asked. Okay. So like this net force should be 0 and potential energy is minimum. If the equilibrium ask. Okay. Next question. Which of the following are true for a point lattice? It is a regular and periodic arrangement of points in space. Each point in the lattice has identical surroundings. It is a random distribution of points in space. Volume of the primitive lattice is larger than the non-primitive lattice. Which of the following is true for a point lattice? Yes, please. We have already discussed unit cells. If you join the lattice points in a space, then we can get unit cell. So, what type of arrangement should be there? Random or regular? Please think about this. 4 point lattice. Please tell me the answer if you have idea. So answer it is a regular and periodic arrangement of a point in space, and also each point in a lattice has identical surrounding. This is the definition for point lattice. Periodicity and identical neighborhoods. This is lattice point about the lattice points. Okay. Next question is this. Pick out the correct statements of the following about the primitive unit cell crystal structure and choice of the state. This is the also lattice thermal coefficient, electronegativity. We have discussed about these things all. So please choose the right options. In previous slides, we have discussed about these things all already. So you can now choose the correct options. Please think and choose the right option. Others, please respond. So let's see. Primitive unit cell doesn't necessarily have to contain one. Sorry, this is I think is wrong. Something is there. Primitive unit cell doesn't necessary to have contain one formula unit for a molecule. Let's say this is incorrect. This is the right answer. Choice of the shape unit cell in a conflict is always unique. And what is the composite mineral have the highest specific strength compared to the metal, ceramic, and polymer? Okay. When we move down in the periodicity table, electronegativity of element increases. This is a type error. Let me check. About periodicity, we have already discussed. We can see electronegativity move left to rightward and increase, and top to down decrease. So for primitive unit cell should be one formula units or should be the one atom. Effective number of atoms one. Okay, and this is higher coefficient of thermal expansion is we have already discussed. I think, and down in periodic table, the electronegative elements increase or decrease. Okay, so there is a typo error. I will correct it and upload on the PPT. Okay, so leave this question. Please go for the next question. Yes, yes. Your voice is not properly to listen. You can type. Next question. Microstructure, feature of a material that can be imaged in a scanning electron microscope is a grain and grain boundary. In sand, we can see grains and grain boundary also. Microstructure feature of the material that can be managed in a system is a grain and grain boundaries. What is grain and grain boundaries? Let's say we have material like that has an image by sand. Scan electron microscope. Okay, so this is called grain, and these boundaries. Take another clue. These these grain boundaries. So we can see grain and grain boundaries. Microstructure feature. Okay. Next question: which of the following could be imagined in a microstructure? This question is about also microstructure. So microstructure, outer bark and optical. This is so please choose the right option. Option is we have already seen cross section image stem of tree and force of fabric. This is force of fabric like that. Okay. So this is the last question I think today. So please learn about this some crystal system and primitive non-primitive relation between the bond length and angles. Okay. Today we have discussed 35 questions. Let me show you one by one. And this is my detail, email ID. If you have doubt, you can ask me by email also. Okay. First question, we have discussed crystalline or non-crystalline. Second question also about same crystalline. Then metal and ceramics comparison. Then character statement about ceramics properties. So learn about these properties of metal, ceramics, glass, polymer. Discussion about this polymer. Then crystal system, symmetry in the crystal system. Also the relation between the unit length system, lengths of the systems and angles. Then coefficient, thermal coefficients. This is simple question about the electron distribution in subcells. Then bonds, bond length, bonds, type of bonds, and unit cell. What are the unit channel and permittivities? Then electronegativity. Okay. Then primary and secondary bonds, range of the bond energy, polymer material again, bond energy and bond. This is bond unit cell again, primitive unit cell bond length, and here is about the equilibrium. This is also important question. Quantities we have to choose correct and incorrect. So something error is there. Let me find out, and I will correct the answers and questions. And about the grain boundaries, microstructure features. Okay, and thank you for your kind cooperation and questions. So please learn these systems. If you have doubt, you can email me. So today's session is recommended. We will meet again on next Monday with the second assignment. You can leave. Thank you.